Hi, this is lesson 7.5, and we will be talking about the side splitter theorem and the triangle bisector theorem in this lesson. First of all, the side splitter theorem says that if a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionately. So in other words, if line RS is parallel to line XY in the triangle, then XR, so this length, is to RQ as YS is to SQ. So the ratio between XR and QR is the same as the ratio between SY and SQ. And here is the proof of that, which uses similar triangles and properties of proportions. So let's apply that theorem. It says, what is the value of x in the diagram at the right? Now the reason, again, remember that we can use this is because of the side splitter theorem, and we have parallel lines here dividing that triangle. So these sides are proportional to these sides. So we can say that 12 is to x plus 1 as 9 is to x. So it's the top to the bottom, top to the bottom. And remember, you can set up proportions differently. You could say 12 is to 9 as x plus 1 is to x. That would work too. So now we cross multiply. So we have 12 times x equals 9 times this whole quantity, x plus 1. And so to solve a proportion, or to solve the equation, I should say, we're going to first get rid of the parentheses by distributing. And now we need to get the x's on the same side, so we'll subtract 9x from the right, which means we have to subtract it from the left. So that gives us 3x equal to 9. And then if we divide by 3, x will equal 9 divided by 3, which is 3. Now if I plug that back in, I just want to show you what happens. 3 plus 1 is 4. So 12 over 4, well, that equals 3. And if we plug in the x right here, 9 over 3, sure enough, that equals 3. Or 3 over 1, 3 over 1. So the ratios are the same. Let's do another one. What is the value of a? Well, again, we have parallel lines here dividing the triangle, so we can say that a is to a plus 4 as 12 is to 18. And we cross multiply. So we have 18 times a equals 12. And again, there's a quantity here, so we need parentheses, because 12 is getting multiplied by that entire expression, a plus 4. And so we'll distribute to solve the equation. And then we have to subtract 12a from both sides. So that gives us 6a, which equals 48. And then if you divide by 6, a equals 8. 6 times 8 is 48. All right, another theorem is if 3 parallel lines intersect 2 transversals, then the segments intercepted on the transversals are proportional. So these are the parallel lines, and these are the transversals. They're lines that are crossing the parallel lines. So the parts that are intersected, so this compared to this, has the same ratio of WX to XY. So AB is to BC as WX is to XY. So basically, those parallel lines cut off those transversals proportionally. So we can use that in a problem like this. 3 campsites are shown in the diagram. What is the length of site A along the river? So here's the deal. We have these parallel lines right here, Okay, these are parallel, and we need to find the length of side A. Well, this is going to be side A. So we need to find this length, we'll call it X. So because these lines, these three lines are all parallel, X would be to 8. So this part would be to this part, as 9 is to 7.2. Okay, so it's side to side, side to side. And then we can cross multiply. So you would have 72 equals 7.2x. So if we divide by 7.2, x equals 10. And then it says, what is the length of site C along the road? Well, this is the roadside down here, and so we need to find this. We'll call that y. And again, we have parallel lines here. So we can take this 8 yards right here to 6.4, and that's going to be 7.2 to y. So side to side, side to side. So we'll say 8 is to 6.4, as 7.2 is to y. Cross multiply. Let me grab my calculator to deal with those decimals. So we have 8 times y equals 6.4 times 7.2, and that's 6.4 times 7.2 is 46.08, and then we divide by 8, and y equals 5.76. So those would both be yards. Okay. Last one. If a ray bisects an angle of a triangle, then it divides the opposite sides into two segments that are proportional to the other two sides of the triangle. So here's the deal. AD is bisecting angle CAB. So I know that because these little angles are congruent. So that means it's right down the middle, bisecting. Well, if that's the case, then CD is to DB, as CA is to BA. So it's the bottom to the bottom equals the top to the top, or I should say the side to the side. So again, this is a bisector right here. So the bottom to the bottom, so 10 to 18 is to 12 to x. So 10 is to 18 as 12 is to x. So 10 to 18, 12 to x. Cross multiply, you have 10x equals 18 times 12, which is 216. Divide by 10, and x equals 21.6. Now I just want to show you that with proportions, remember, we can use our properties. You could do bottom to side, so 10 to 12, and bottom to side, 18 to x. And you'd still get 10x equals 12 times 18, which is 216, which is going to give the same answer. You just have to be consistent in how you set it up. So in this next one, either way that you want to do it, if you want to go bottom to bottom, and then side to side, or you could do side to bottom. So this to this equals side to bottom, 24 to 16. And when we cross multiply, either way, you get 16y equals 24 times 9.6 is 230.4. And then we divide by 16. Y equals 14.4. Here, again, 16y equals 9.6 times 24, and that's going to be the same thing, that 230.4. So you'd get the same answer. All right, just a few little problems here. It says use a figure to complete each proportion. So A is to B as what is to E. A is to B as what is to E. Well, it's going to have to be D is to E. Okay. Next, B is to, well, let's do it this way. Let's read E is to F. So E is to F as B is to, well, have to be C. So just look for the patterns on these. And then the next one is A is to B plus C, so that'd be this whole thing, as what is to E plus F? Well, that's going to have to be D. In the next one, it says, what is the value of X in each figure? Well, here again, we have the parallel lines inside the triangle. So the sides are going to get divided. This is your side splitter. So X is to 10 as, let's see here, it's going to be basically this little part to this part of the triangle, and then this right here, but we don't have a length right here, so we have to do some figuring first. We know the whole thing is 45. From here to here is 30, so if we do 45 minus 30, this little part right here is 15. So we can say X is to 10 as 15 is to 30. So the little part to the big part, little part to the big part. So 15 to 30. See how I did that? So X to 10, 15 to 30. All right, next thing we need to talk about is use the given information to determine whether BD is parallel to AD. This is a little bit different than what we were looking at, but we're using kind of the same idea. We aren't given the fact that these lines BD and AE are parallel. It doesn't say that. However, if they are parallel, well then the sides would be proportional. So there's a few different ways you could do it. You could write a proportion. You could say 3 to 6, or you could look at the ratio, I should say. Look at the ratio of this side, look at the ratio of this side, 3 to 6 and 4 to 8. So a few ways you could do that. You could say, what does this ratio 3 over 6 equal? It equals 0.5. What does this one equal? It equals 0.5. They're equal, so that means the ratios are equal to each other. So yes, it's a proportion. The other thing you can do is use the means extremes property that says if you have a proportion, cross products are congruent. So if you do 3 times 8, that equals 24. 6 times 4 equals 24. So yes, those are proportionate. So that would prove to you then that the lines are parallel. So you could say that AE is parallel to BD because those segments are proportional. Let's look at this next one. We're trying to decide if AE is parallel to BD, so we can write a proportion. So 1 is to 2 as 1.2 is to 3. And again, those are a little bit harder to reduce a fraction. I mean, you could just divide, but we can also cross multiply and see if it's true. 1 times 3 is 3. 2 times 1.2 is 2.4. Not equal, so they are not parallel. So set up a proportion, cross multiply when you're testing to see if the lines are parallel. Or you could also reduce each ratio and see if they're equal. Let's just do one more here. So we want to determine if these lines are parallel. So we can do 6 is to 10. So 6 to 10 as 9 is to 15. Cross multiply, you get 10 times 9 is 90. And 6 times 15 is also 90. So yes, lines are parallel. Or you could just say, oh, that we don't have letters. I was going to say you could name the lines, but we don't have that information. So that's what we do. Set up a proportion, cross multiply. Or you could do, what is 6/10 equal? Well, that equals, let's see, 3 goes into 6 twice. How about we try something else? 2 goes into 6 3 times, 2 goes into 10 5 times, 3 goes into 9 3 times, 3 goes into 15 5 times, so they're both 3/5. That'd be another way you could prove it. Reduce the fraction, see if they're the same. or cross multiply. Either one works. And that is it for this lesson, and this is the assignment to work on. Thank you for watching.